Welcome everybody, my name is Dr. János Vince. I am the Research and Development Director of Labtech, a leading Hungarian manufacturer of ECG devices. In this short video tutorial, I will show you how to efficiently analyze Holter ECG recordings using our CardioSpy software. When you connect a recorder to the computer using the supplied USB cable, CardioSpy automatically reads and analyzes the ECG record on the recorder. So we will start from this point where you see the result of the initial automatic analysis and start to do the manual post-processing to ensure the quality of the analysis. This is the main screen for Holter ECG recordings. In the bottom panel, you see the ECG signal itself for all of the channels in case of 1, 2 or 3 channel records, or for at most 3 channels in case of 12 channel records. On the left of this panel, you see the so-called median heartbeat, which is the average of 10 heartbeats of the dominant form around the currently selected heartbeat. In the top panel of the screen, you will see 2 graphs. One graph, which is mostly green and somewhere red, shows the heart rate of the patient at the given time. The color of the graph is green if it's within the normal limits, and it's red if it's outside the normal limits. This convention is used throughout CardioSpy so that you will be able to spot abnormalities easily. The other graph is the orange graph behind the first graph. This graph is for the data coming from the built-in accelerometer, and it shows you the physical activity of the patient during the day and possibly also during the night. In the middle of the screen, you see various trends. By default, the QT and ST trends are shown. However, you are able to change these graphs to something else if you wish. As the very first step of the Holter analysis, I always suggest you to quickly glance through the ECG signal to check for any major abnormalities that would require a repeated Holter ECG examination. If you check the general signal quality and believe that the recording is suitable for further analysis, you can use this sequence of tasks menu, which brings up a cheat sheet of the most important tasks in the Holter analysis, and it will also show you the preferred order of them. Normally, this window comes in this collapsed form, where you are only able to see the list of steps and mark each step as completed. However, there is a possibility to expand the window and also check when and by whom each task was completed. So let's see the first task, the evaluation of the QRS template. If you click on the name of the task, it will automatically bring the correct screen up for you. CardioSpy uses templates as a way to make Holter ECG analysis efficient. So it is very important to understand this screen, and also to correct the templates for each evaluated Holter ECG record. The bottom of the screen also shows the ECG itself, like most of the other screens in CardioSpy. However, the top panel of the screen is very different from what we have seen in case of the main screen. Here you see the templates in the decreasing order of the number of beats belonging to each template. A template contains heartbeats which are similar to each other on all the three channels. For each template, a representative beat is shown, an overlapped image is shown on the left, and if you select a template and scroll in the ECG, you will only scroll through beats that belong to that template. A template is considered correct if there is only one major morphology of the heartbeat for each of the channels. You can see that since this template contains many heartbeats, more than 78,000, there will be small variations around that dominant morphology on each of the channels, but there is no other secondary dominant morphology, so this template does not need either manual or automatic demixing. You may want to adjust the size and the contrast of this display for your screen to show the dominant waveforms and the variations around them more clearly. So we can say that this template is correct, and if you wish, you can mark it with a green tick. Also, it is important not only to determine if the template should be demixed or not, but also to determine if the beats in the template have the correct marking. In case of this template, by looking through the beats belonging to the template, we can say that the normal beat marking is correct for this template, so we will not change it. And we can go on to the second template. In this case, you are able to see a secondary dominant waveform on channel 2, so you just select an area where only the secondary waveform is visible to demix this waveform from the rest of the template. You can see that the resulting template is much clearer, and it is very easy to look through this much clearer template and confirm that the supraventricular designation for this template is correct. We move on to the third one, which is a bit noisier than the previous ones, but it is also marked as normal. However, by looking at the individual beats in this template, you can see that some of them are plain noise, and there could even be beats which are not normal, like this one. In this case, since most of the beats are still normal, what you can do is to manually mark those beats that are not normal as ventricular or whatever they are, and marking a beat differently from its template will automatically remove that beat from the template. So we believe that most of the other beats selected here are either normal or noise. In case of noisy beats, you can select noise deleted so that the beat would be removed and the surrounding area of the ECG would be excluded from statistical calculations, so noise would not affect those calculations negatively. If the majority of the beats in this template would not be normal but rather something else, which seems to be the case here, you could rename the whole template to something else, and it is possible to keep those beats which are correctly marked originally by fixing them. If you fix a number of beats and then rename the template, the fixed beats will remain in the original template, and a new template will be created from the non-fixed beats. In the forced template, you can also see that there are more than one dominant waveforms, so you can easily decompose them. The fifth one looks okay. Just like the sixth, which is mostly okay, however it contains lots of noisy beats, which normally you would want to fix, but I will not do it in case, because I've already shown you how to do this. I will just skip the other templates and get to all these with a very few number of beats. Since normally when you do a Holter ECG recording, you are not looking for abnormalities that manifest themselves in only 1 to 15 heartbeats in a 24-hour recording. To speed up analysis, you can select all those templates which contain less than 20 or less than 15 beats and mark all of these as noise. This will of course remove some of the genuine QRS complexes from the analysis. However, it also ensures that most of the noisy sections of the ECG are excluded from the analysis and the statistical calculations, so that the overall report will contain correct results. This is all that I want to say about this template screen. Just to briefly summarize what we've learned here is that it is very important to correct the templates, because all the subsequent analysis relies very heavily on templates, and if they are incorrectly grouped, then this incorrect grouping can cause serious issues in the further steps of the analysis. So we can mark QRS templates as completed. You can see that the date, name and software version is automatically logged. The logging actually takes place even if the window is in its collapse form when you finish a step. The next step is the analysis of the RR intervals. The analysis of the RR intervals is very important because one of the main questions for each Holter ECG record is the minimal and maximal heart rate for the patient. To determine this, you would use this RR interval or HRV screen and move this cursor to the left. Then click here and move to the right until you find the first valid RR interval. In this case, it seems to be here, so that you could then click on Fix Min and drop all the RR intervals shorter than the one valid you have selected. You can do the same with the maximum RR interval. Also, if a recording contains many non-normal beats, you may want to separately do this for the NN intervals. So we have completed the RR intervals and now continue with checking the record for atrial fibrillation. To evaluate the presence of atrial fibrillation, you could of course look at the ECG signal itself. However, for such long record, the most telling display for atrial fibrillation analysis is this NN intervals graph. This recording contains no atrial fibrillation, therefore the NN interval graph is normal, with a clear dominant NN interval at all times, which changes in the opposite direction of heart rate changes. So this is what you see in case of normal recording. You can see the sections that are marked as atrial fibrillation here. If there was a longer section marked as atrial fibrillation, it would appear as a red stripe. However, in this recording, two very short sections were automatically marked as atrial fibrillation, as indicated by these red markers. If you want to remove even these two short sections, you should hold down Shift, select the area containing them, and tell the program that the selected range is not atrial fibrillation. So we have now completed the analysis for atrial fibrillation. And we can go on to the ventricular events. All the subsequent steps would be on this screen, which is the main event screen. Here you see one black line for each occurrence selected event, and also the number of occurrences in the given hour. If you actually select one of the events, you will see the occurrences in the top panel as well, And if you scroll the ECG, you will only scroll through the occurrences of that event, so you can check if those are real occurrences. Here we can we actually have a couple of 100 ventricular beats, and quickly scrolling through them reveals that most of them are correct. There are some ventricular pairs or couplets. There is no ventricular tachycardia, with some episodes of ventricular bigeminy or trigeminy. So we've completed the ventricular event analysis and followed, and we could do the same with supraventricular events. There are actually a few thousand supraventricular ectopic beats, some pairs, no tachycardia, and some trigeminy. You can check and verify that these are indeed episodes which belong to this event group. Oh, excuse me, there is actually one episode of non-sustained supraventricular tachycardia, which is indicated as the longest and fastest supraventricular tachycardia episode. So once we've really completed the supraventricular events analysis, we can go on and look for the minimal, maximal RRNN, which we've already checked, so there should be no surprises here, and also for the minimal and maximal average heart rate. You can complete this step as well, and then have a look at the minimal and maximal QT or QTC episodes and decide if they are within the normal limits. You would also probably want to have a look at the QT and QTC summary graphs and tables which are on this screen. If you complete this, we have basically completed all the steps of the Holter analysis, and we can view the summary of the results in the summary window. The very last step is to write an interpretation, which you can do using the built-in text editor that can be opened by this button. In this built-in text editor, you can type your text freely, or you can import the automatic report or one of your own templates. In this case, I will import the automatic report, which will bring in most of the parameters and text from this summary into the report. However, in this text editor, you are free to edit any of this report. You do not have to save the text. Just by closing this window, it will be automatically saved. Once you complete the interpretation, you can tick this box to say that you have approved the evaluation. This will prevent further modifications of the record unless this box is unticked. So this is not a safeguard against malicious activities. However, it can be effective against innocent mistakes and prevent editing of already analyzed records. we would, in order to get a report of the analysis, you can either click here to print a report or click here to save the report in an electronic format. Each of these, in either of these screens, you have the option to select which pages you would like to include in the report, and you can increase the number of copies to more than one if you wish. Normally you will not want to have the total report containing more than 40 pages, just some of the summaries and maybe some of the trend and event summary pages. The printout of the full ECG is certainly not needed in most of the cases. Once you set up which pages you would like to use, the settings here would be carried over to the next recording, so this is something that you will have to do only once. Typically the settings for the printer and the printing itself will only have to be done once. You should be able to select if you want black and white or color printout, and also lots of other options. Once you have these, you can click on print to print the record, or if you open the export window, then to save the report in your preferred electronic format. So this was how a demo record could be analyzed